Welcome to Saxon Course 2, Lesson 21. We're going to deal with prime and composite numbers, and we're also going to talk about prime factorization. We're going to identify and list prime numbers. We're going to identify and list composite numbers. We're going to write the prime factorization of composite numbers, and we're going to use both division by prime numbers and a factor tree to factor composite numbers. For a vocabulary, composite numbers is any number that has 3 or more factors. So for example, 6 is a composite number because 6 has the factors 1, 2, 3, and 6. That's 3 or more. It's 4 total. So that would be a composite number. Factor tree looks just like this, where we start with a larger number and we break it down into the smallest prime numbers that make it up. Prime factorization is writing the composite number as a product of the prime numbers. You can see here that 420 is a composite number. The prime numbers are 2, 2, 3, 5, and 7. Prime numbers are exactly 2 different factors. Any number that only has 2 factors, itself and 1, is a prime number. We remember that counting numbers or natural numbers are the numbers that we use to count. They're 1, 2, 3, 4, 5, 6, 7, 10, 15, 16, and on up. Counting numbers greater than 1 are either prime or they're composite numbers. A prime number, like I said, has exactly 2 factors. A composite number has more than 2. So all these numbers that I circled, 2, 3, 5, and 7, they're all prime. 1 is not. And the reason why 1 is not prime is because it does not have 2. It has to have 2 factors, and 1 only has itself, which is the number 1. All of these other numbers, like 10, are composite numbers because they have more than 2 factors. So make a list for me of the prime numbers that are less than 16, knowing that a prime number can only have 2 factors. See if you can do that, please. You should have listed numbers 2, 3, 5, 7, 11, and 13. All the other numbers are composite. They are not prime. Now list the factoring pairs for each of these numbers. Do you remember what a factoring pair is? So for 14, a factoring pair would be 1 and 14, 2 and 7. Right? Those would be factoring pairs. What are the factoring pairs for 16, 17, and 18? Pause the video, please. Write them down. See if you did it right. Factoring pairs for 16 are 1 and 16, 2 and 8, 4 and 4. The factoring pairs for 1 and 17 are 1 and 17, and the factoring pairs for 18 are 1, 18, 2, 9, 3, and 6. So which of these 3 numbers is a prime number? It's 17 because it only has 2 factors, 1 and 17. List of the composite numbers between 40 and 50. So first thing we're going to do is we're going to list them, 41 through 49. Now we need to determine which of these are composite and which are prime. Now there's some shortcuts that you can do. I'm going to go ahead and walk you through this. Any number that's divisible by itself and 1 by a number besides 1 in itself is composite. So all of the even numbers in this list are composite. All right, so this is composite because it's even. It's divided by 2. These are all composite because they're divisible by 2. So that leaves just the odd numbers to consider. We quickly know that 45 is divisible by 5, so we can take that off our list. And that 49 is divisible by 7. We know that. So the composite numbers that are left over between 40 and 50, or the ones that are remaining, the 41, the 43, and the 47, these 3 here are our prime numbers. So we know that all of these other ones, 42, 44, 45, 46, 48, 49, are all composite numbers. Prime factorization. Every composite number can be broken down by multiplying 2 or more prime numbers. Here are shown each of the first 9 composite numbers with their prime factorization. So 4 is our first composite number we come to. It's got 1 and 4 and 2, so it's got 3 or more factors, so it's composite, but it breaks down into 2 times 2. Those are the prime factorization for the number 4. And we do that, for example, 8, number 8 right here. It has the factors of 2 times 2 times 2. It's not 2 times 4 because 4 is not prime. So we got to break that 4 down into 2 2's also. So you have the 2 times 2 times 2. So we get the 3 2's. We have a couple ways that we do factorization. One is a factor tree, which is the preferred way. Another is if you're really crazy about long division, which I know all of you just love it to death, you can do it that way also. You start with the number and then you get smaller. We'll practice both. So write the prime factorization of 81 using a factor tree. I'm going to do 75 for you, just over here on the side, and then you can use that as a guide. So 75, that will be divided by 3 and 25. I know that. And then my 25 can be divided by 5 and 5. I'm done because 3, 5, and 5 are all prime numbers. So I know that the factor for 75 is 3 times 5 times 5. That would be my answer for the prime factorization of 75. See if you can do it for 81 and come up with the correct answer. You should have came up with 3 times 3 times 3 times 3. Now, how would you show that exponentially? Be like this, 3 to the 4th power. That's how we'd write that if we didn't write it 3 times 3 times 3. Now, looking at the next one down, write the prime factorization of 360 using the divisions of primes. Okay? That's the one where you're going to take 360 and you're going to divide that in half. And you're going to have 180. You're going to divide that in half if you can. If you can't, you're going to go to the next prime number. I'm going to show it to you rather than have you do it. So you start off with 360 to be divided by 2. And then that leaves you with 180. And 180 can be divided by 2, which makes it 90. 90 can be divided by 2, which is 45. 45 no longer can be divided by 2, so we divide it by 3, which leaves us 15. 3 goes into 45 15 times, and 15 divided by 3 is 5, and we're done. So our prime factorization using this method for 360 is 2 times 2 times 2 times 3 times 3 times 5. How would you write that exponentially? 2 to the 3rd times 3 to the 2nd times 5. Write prime factorization of each of these numbers. So go ahead and use your factoring tree. See if you can do 30, 81, and 42. Let's start with 30. Go ahead, work it, and then start the video. Hopefully you came up with 2 times 3 times 5. Now do B, number 81. What's the prime factorization of 81? We know that from the prior screen, 3 times 3 times 3 times 3. And can you do 420? Remember, start with 2. Try to use the smallest prime numbers possible to begin with. So on 420, you're going to have 2, you're going to have 210. Can you split this by, is this an even number? It is, so 2 and 105. Split that up. Just keep on going down. See if you can do C. You should have came up with 2, 2, 3, 5, and 7. C obviously was the harder of the 3. Write the prime factorization of 100 and of the square root of 100. Practice it. See if you can do it. The prime factorization of 100 is 2 times 2 times 5 times 5. And for the square root of 100 is 10. And 10, when we factor it, it's just 2 and 5. So you notice that they're both made up of 2's and 5's, but 100 has twice as many as the square root of 100 because it's the square root. Write the prime factorization of 36 and 60. Once you do that, you can use those results to find the greatest common factor of 36 and 60. Once you've found the factorization of each, so for 36, you should have found that 2 times 2 times 3 times 3 on your factor tree, and then for 60 was 2 times 2 times 3 times 5. If you put them one above the other like they have here, and then you circle the ones that are in common, and you could do it like this here, right? If there wasn't another 3 or something, you know, just so they're in common. What you end up with is you end up that both of them have a 2, they both have another 2, and they both have a 3. If you take these and you multiply them together, 2 times 2 is 4, times 3 equals 12. 12 is your greatest common factor that'll go into both these numbers. 12 goes into 36 3 times, and 12 goes into 60 5 times. That's the biggest number that goes into both of those. And that's how you can find the greatest common factor of two numbers very quickly, is by factoring each one of those down and then finding out which ones they have in common. And you'll do a lot of these on your homework and do a lot of practice with this. So get this method down. Here's your tickets out the door or in the door. Number 6, 7, A, B, and C, and 22. If you have any questions, bring them to class, please. We'll see you tomorrow. Thanks for watching the video.